Hi folks, so we're getting into a new chapter which involves polynomials and so forth. But before we look at polynomials, we first need to check out power functions, and that's what this class example sheet is designed to do. The reason for that, as you will see later, is that power functions are what make up polynomials. So we need to know something about power functions before we get to polynomials. So let's go ahead and get into it. So I'm going to talk about some of the problems you'll see on this sheet and should help you with completing everything on it. As you can see, pretty much as long as we can write a function in this form where it's a constant number times the variable, can be x or whatever your independent variable is, then raised to a constant exponent. If you can write a function that way, then it's going to be a power function. Okay, the exponent that's on the variable is a lot of times referred to the degree of the power function, but that's only if that exponent is a whole number, which is most of the time what we're going to deal with in this chapter. So that's a good thing. So here's some examples of power functions, right? 2x to the fifth. That's very typical of what we might see in our work in this chapter. But you can get a little fancier. I mean, it can be any constant. So root 3 is a constant, right? 2.74 is a constant. So we don't have to have whole number exponents. We don't have to have whole number coefficients, right? That's what we call the number multiplying the x. It's a coefficient. All right, and then here's another example of where we could have a fraction for the coefficient. We could also have a fraction for the exponent. Okay. So all 6 examples in number 1, you're looking at 3 of them, are power functions. So your job is to figure out what is the k and what's the p. Okay, some of these may be easier than others. Certainly with part A, I think I'll withhold what I'm going to say about that till later, give you a chance to figure out what k and p are for that. With letter C here, I'll just point out, we can rewrite this as pi times x raised to some exponent. So I'm going to let you figure out what that exponent would be. Okay, but your k would be pi here. For letter E, let's just think real quickly, what is the exponent on x here if you have a square root? Yes, so the square root, right, is the 1/2 power, right? A cube root would be 1/3, fourth root 1/4. So this is x cubed divided by x to the 1/2, and that can be written as x raised to some power. All right, let you figure out what that's going to be. All right, so why don't you pause the video and try these 3. I know the numbering is weird. Usually I go across A, B, C, but this time the computer decided to do something different and I didn't catch it. All right, so pause the video and see if you can finish these. Remembering each time you need to say what K is and what P is for each of these. All right. Let's move to the next page and I'll give you some hints for those 3. So for letter B here, you might recall we do have a property that we can apply here with square roots, that when it comes to products of square roots, right, we can split them up. So this would be the same thing as root 3 times root x, and therefore you could write it as some number times x raised to a power. I'll let you finish that. Not going to say much about letter D, just simplify it, and then I think you can write it as something times x to a power. And then F might seem a little tricky, like where's the x here? But we can write this as 2 times x to some power. The question is, what is the exponent that would go on there? Keep in mind that 2 is the same thing as 2 times 1. So if there's a way you can get x to an exponent to equal 1, then you've got it. All right, well, hopefully those hints will help with all 6 of these parts, and then we can check it when we meet again. Let's take a look now at graphs of power functions. As I said before, we're going to be dealing with power functions mostly in this chapter that have whole number exponents. All right, so I want to just kind of remind us what the graphs of these power functions look like. And in fact, if you go back to chapter 1, to things you did in chapter 1, you will actually see this number 2 on one of the sheets that we did. So I just basically went to one of the, I don't know if it's an exploration sheet or a class example sheet from chapter 1 and copied number 2 on here, where you've got to draw, the graph of x to the first, x to the second, x cubed, x to the fourth, and you go on up, and then hopefully you're picking up by then on a pattern to the graphs, and then you could do x to the 67th or 68th power, and it's not a problem. So if you want to look back and find that, maybe it would save you some time, or maybe just, you guys know what x to the first looks like. You should know what x squared looks like, and then x cubed, and kind of just go from there. All right. On number 3 here, it's not going to be very different from number 2. I mean, your graphs are pretty much going to look the same. I mainly am just wanting to see how you react to when there's a negative in front of it, okay? I know there's a 1/2 here, but generally I just, I think it says up here, let's see, sketch the general shape. So you don't have to give me specifics that would let me know, oh, there's a 1/2 in front. We do know that would be a vertical compression by a factor 1/2, but I'm mainly interested in just the general shape, and when you see a negative, what does that do to your graph? All right, so what would you do for parts A and B on this? Right? Why don't you pause the video and give that a shot, and then you can check with what I do. Okay, see if this is what you did. While both these graphs may be a little compressed vertically, like they go out a little wider than what your x squared graph did, the main thing I'm looking for is that this one's concave up, right? And this one with the negative on it, right? We would reflect over the x-axis, and it should be concave down. I didn't do a great job of sketching this. It should be a little more symmetric with respect to the y-axis. Okay, but that's the main thing you're doing in number 3. So pay close attention to whether the coefficient in front of your exponent is positive or negative, and react accordingly to that. All right, I hope that helps with tips on this, and we will check this sheet the next time that we gather.